Hello everyone, my name is Leanne Hersey with Desalitech, and welcome to our mini webinar entitled 3 Ways to Improve Food and Beverage Operations with Smart Water Tech. So a little background on this webinar. We thought this was a timely webinar topic because there is constant news on the topic of automation, robotics, and smart tech in the food and beverage industry. Although this is already quite an interesting topic, naturally at Desalitech we focus on water and water use. So if your organization is looking to improve water efficiency, it's important to stay current on the water tech that can help you to do that. So we've curated a small but helpful list of water tech that can help jumpstart your journey and improving your water efficiency and operations. This is because at Desalitech, we want industrial water users to be confident in their water operations and also have an overall confidence that their facilities are doing as much as they can to reduce water use and to use water more efficiently. And with water cost having increased in the US by 50% since 2010, this is a smart choice economically as well as for sustainability reasons. Saving water can do a whole lot of good for your bottom line and for the environment. What I'm showing to you here on the screen, this is not specific to the food and beverage industry, but I found this map to be quite interesting. It's showing us the number of robots per worker by geography, and it's astonishing, really. If you think back through the last decade or two, we would absolutely not be seeing this. And I bet if we include more general forms of automation on this map, it would be entirely covered. We are seeing this growth in automation, robotics, and smart tech in the food and beverage industry and in many others because we implement these things to help us become more efficient, and it's working. Getting back to the food and beverage industry. According to a recent survey by the Association for Packaging and Processing Technologies, almost 1/3 of food processing operations are using robotics, and 94% of packaging operations say the same thing. Both groups say they will use more in the future. And elaborating on that, half of companies interviewed for the survey said that they are focused on increasing the level of automation in the next 3 to 5 years, and they have a plan to increase spending on capital equipment in the next 2 years. So, the first way I'm discussing today to improve your water operations with smart tech would have to be with water purification systems monitoring. So almost all food and beverage processing facilities require some way to purify water, whether it's for, say, ingredient water in a product or some sort of heating or cooling application like boilers and cooling towers. Most facilities these days require purified water for one of these processes, and they also want to look at recycling some of that water for reuse. So there are many ways to monitor your water purification. The point of monitoring this is to arm yourself with data, right? That's the bottom line. So getting good data can be as simple as walking over to your water purification system, looking at that PLC screen, say, every Monday at 10 a.m. and recording the data. This is a very basic and low-cost way to monitor your water purification system. And as long as you're checking in at the same time each day and continually recording data, once you have a critical mass of data, you'll be able to see trends and start to learn where you can optimize your system. So here in this 2x2 matrix, where we compare complexity versus cost, you can consider this option very low cost, and it's a very uncomplicated way to get started with your data monitoring. This would also be a great place to start if you're new to operating a water system. This would help you really learn the fundamentals and get a firm grasp on exactly how the system operates and what factors contribute to changes in its operation for better or for worse. So if you're interested in having more granular data, implementing an online monitoring system for your water purification is essential. You'll see this option is a little more complex. However, the benefits are plenty. These are generally cloud-based. However, you can store sensitive data on your own servers when needed. But these provide indispensable operating information to the plant operators and supervisors. This is generally enabled by a software that will need to be integrated by your water purification provider to your water purification system. We see them most commonly on reverse osmosis systems because RO is a very common way to treat water for the food and beverage industry. So these are very, very common and very widely used. Sometimes this software will be offered by a third party, or it may be a proprietary software that's only available in conjunction with a certain water purification system or product. We'll touch on that in a bit, in one moment. So once implemented, specially placed sensors will measure flow, pressure, conductivity pH, temperature, and ORP. So, referring back to the matrix, a more premium option would be an online monitoring system that also offers remote monitoring and alerts or alarms, plus preventative measures. A system of this pedigree will provide alerts and alarms to inform the operator of any issues or potential future issues. The operator will be notified via email or text if there are any important issues, and they'll also be provided the option to log into an online portal to see data visualization and reports on system operation. If you have an existing IoT functionality in your facility, this can easily be linked to other systems across your enterprise to provide you with a 360-degree view of your operations and, of course, associated water use. This can be an indispensable tool to organizations with multiple facilities, since water can oftentimes be siloed via each location. We're not always sure what that full picture is. But it's not just a solution for enterprise-sized organizations. It's also a huge help to those who may have a smaller facility and need the extra support, but may not be able to staff a large team of water operators or even a large team at all. So having a software like this frees up the water operator, frees them up for other tasks. He or she may be in charge of an entire facility and not just water operations. So it enables them to spend time on tasks instead of worrying about the water operations. Next up on the list are innovations in anti-scalant technology. This is again mostly focused on membrane-based water purification methods, primarily reverse osmosis. Again, it's just simply because it's so popular and so widely used in many food and beverage processing facilities. So we thought this was quite applicable. What I wanted to cover here is that this is an anti-scalant tracing technology that's based on an injectable and UV traceable chemical. What they do is dose it into feed water of a reverse osmosis system, and then it's measured using a UV sensor. This enables the water operator to easily read the dosage of the anti-scalant. And now it sounds simple, but this has big results. It helps to minimize waste in water through improved recovery. It can help to save energy by maximizing throughput and minimizing downtime. It's also helping to minimize maintenance cost by optimizing the treatment program, right? So you're using just the right amount of chemical, the right amount of anti-scalant, no more, no less. It also has the potential to increase membrane life because if you can use the right amount of chemical to reduce cleaning frequency, then you're going to clean your system less often, and therefore you're going to have less downtime. These UV traceable chemicals are used in conjunction with an online monitoring program. So if your interest was piqued when I first mentioned online monitoring, then using it in conjunction with these smart chemicals is going to be a big step up for your current reverse osmosis system. So in summary, online monitoring and chemical tracing are both excellent ways to avert a serious problem or a system shutdown. If you have a large team or organization, this helps you get better data and intel into all of your facilities and helps your team make smarter decisions when it comes to water. If you have a small operation or a small team, maybe both, these are going to help you free up your time to focus on other things. Don't just be a slave to your water operations, right? Make it easy so you can focus on what matters. That means production, things like that. However, if you are currently operating reverse osmosis and are unhappy with its performance as far as recovery, uptime, energy use, or the simple fact that it requires a lot of babysitting, which the previously covered topics do help to address a bit, but if those are issues that are bothering you, then the last bit of smart water tech I want to introduce is called closed circuit reverse osmosis. If you're familiar with traditional 1, 2, or 3-stage reverse osmosis schematics, you likely know that fouling, scaling, water recovery rates, and uptime are generally a constant struggle for the water operator when he or she is dealing with RO. The more stages you have, because you want higher recovery, so you add more stages. The more stages you have, the more operational sensitivity you deal with, due to the inability to balance flow rates between membranes. This, in turn, limits overall recovery rates and accelerates membrane clogging, like fouling and scaling. These require shutdowns to clean, and if it's really bad, it can even require the replacement of membranes. This is absolutely something you want to avoid, since membranes are a costly component in any membrane-based water purification system, so you want to avoid the replacement of membranes at all costs. When you're dealing with a traditional RO system, if your feed water changes at all, the likelihood of a shutdown for cleaning increases exponentially, and you'll be certain to see a decrease in your water production at the very least. But with RO having been the gold standard for so long, I'm sure you're nodding your head right now if you have an RO system. These problems seem like a necessary evil. There is a growing market for an alternative RO process, which I personally believe is going to be the gold standard very soon. This process is called closed circuit reverse osmosis, which offers an automated approach to water purification. Which, by the way, this does work well with the 2 services and products we covered before, but if your inherent issue is your RO system, if you're constantly having to clean, if you're constantly struggling and dealing with headaches from its operation, you're going to want to take a closer look at closed circuit RO. These closed circuit systems constantly purify feed water while periodically flushing the concentrated waste before clogging. So this is going to help to prevent fouling and scaling, because at the point where most membranes would start clogging, the system simply flushes the waste and new feed water comes in. By controlling the flow, the number of cycles, and the variation of pressure and concentration prior to each flush, CCRO systems, these closed circuit systems, are uniquely resistant to clogging, from fouling and scaling to biological growth. The system adapts automatically even to extreme changes in feed and operational needs. If a requirement of yours changes, you can simply dial in new parameters and the system adapts. It's not statically designed like the systems of the past, and even a lot of the RO systems today that are sold, because those are mainly just RO systems, they're not closed circuit RO. Because of the unique process that CCRO offers, it's able to save water, energy, and reduce fouling and scaling. So when we look at traditional RO and CCRO head-to-head, average water waste is generally reduced from 25% with traditional to less than 5%, oftentimes 2%, because CCRO will operate at a maximum high recovery. Say a traditional RO system is getting 75%, 85% water recovery. A closed circuit system will be getting that 90, 95, even 98% recovery. So that's reducing your waste quite a bit. It generally reduces waste by about 80%. Right now, we're looking at an osmotic pressure chart. I'm showing you this because closed circuit reverse osmosis systems use about a third of the energy of a traditional system. They use just enough energy to overcome the osmotic pressure. The process is more reliable and adaptive with less need for maintenance and oversight, which is essentially the point of this presentation, to help make saving water easier. So this concludes the presentation for today. I hope you've enjoyed it. I hope you've learned a little something. I'd like to reiterate strongly that if you're looking to improve your water operations, any of these improvements mentioned today in water tech are sure to help you start saving water and water costs. If you are not ready to implement any of these, that's fine. Use our previously mentioned tool. Just go to your system every day, start monitoring it, look at all your data. The important thing is arming yourself with the tools to gather and analyze data. Data is key. And when you're adding smart tech and automation to your facility, these help you to achieve your goals. If you're new to the water treatment industry, in the food and beverage industry, or even if you've been in the business for years, there are always new processes and new tools to help you save water. And with such a precious resource, and with the amount of savings your facility or your organization can stand to gain, this is something that everyone needs to take a closer look at. If anyone has any questions about what we discussed today, you'll see my contact information on the screen. I want to thank everyone for joining. And I know some of the images, particularly the osmotic pressure chart, was a little bit hard to see. So if you'd like your own copy of the full report that includes that chart, please do feel free to email me and I will shoot it right over to you. If you're looking for a free assessment on your water tech, you can also send me an email and we can have one of our engineers take a quick look at what you have going on and see if we can help. Thanks everyone for joining and have a wonderful day.